So today we're going to see a configuration of the artifacts from the Viking Mars mission that you've seen before independently. This is the Viking Mars mission Education and Preservation Project, and we preserve the artifacts, archives, and oral histories of the individuals that worked on the Viking mission, from NASA centers to manufacturers and subcontractors, as well as academics around the world. So what I'm going to show today very briefly is how these individual artifacts were arranged in a system. And this particular system is the descent engines for the Viking lander. And in this image, you can kind of see a very early rough drawing of what that looked like, very early. And so normally, as you see, this whole system would be upside down, facing down, but I obviously can't do that in this demonstration. So this particular system is made up of a combination of flight qualified artifacts as well as test units. So this particular piece here, the first piece that I'm going to remove, is a test unit, and these were the nozzles, an 18 nozzle system, and the nozzles were designed to cause the least disturbance possible on the surface of Mars during the descent, because the scientists themselves were actually trying to study the surface, the characteristics, the regolith, the materials and elemental and chemical properties, and they wanted to disturb it as little as possible. So this unit here has a nozzle that was used for potentially two purposes. One purpose was to introduce very high velocity air into a closed chamber system so that they could simulate a landing and get an understanding of how much force would disturb the surface of the planet. The other possible use for this particular piece was to do a test on the pressure test for this particular unit itself as well. So both of those things were done to multiple test units. All right, let's move on to the next piece. You can see inside this test unit a little bit there. So the next thing you see in configuration here are the other pieces. The two concentric circles that you're seeing here are catalyst chambers, and they would hold inert catalyst with smaller pieces in the outer chamber and larger pieces of the inert catalyst in the center chamber. And into this chamber, the hydrazine propellant would actually be pumped at high velocity again, and there would have been a different piece on top of these that would have distributed them directly to the nozzles, but we do not have that piece. So in this case, these are very high temperature tempered steel. You do see some of the unit numbers on here, serial numbers. These ones were flight qualified and designed. This particular piece here that I'm going to take off next is a thermal chamber that, as you could see, contained the concentric chambers for the inert catalyst, and it also was to protect the craft from the heat during the ignition process and to make sure that the temperature within the system itself would be fairly constant during the ignition process. So this is a thermal chamber, and this is not a flight qualified unit, this particular piece. We'll put that over here. And this piece here is, you can kind of see what it looks like on the inside as well, the outer shroud. And again, you can actually kind of see where it would be up here, correspond. And this is gold-plated titanium. The gold-plated titanium was used because it was highly heat conductive. So in order to cool the system down, they wanted something on the external shroud that would be very heat convective, which would pull the heat away from the entire system into the atmosphere, which was very, very cold, and that would help with the cooling of the system and prevent secondary combustion or explosions. So again, this is gold-plated titanium, very, very lightweight if you look at those. If you feel them, you can actually see how lightweight it is. It's pretty remarkable. In this particular system, I'm going to move this over here out of the way. I don't want to get my fingerprints all over it. This piece right here, I'm going to put this back on so that you can kind of see how they would have been attached. This is a flight qualified unit, and you're going to see when I lower this that they don't actually fit together. So these screw holes here do not actually meet up with this unit here because this is not flight qualified and this particular piece is. So the screw holes on the bottom piece do not match up with the screw holes on the top piece. But you can still get an idea of the gross configuration and how they're attached. Now this particular piece would have been attached to the body of the spacecraft. In this way. And if we put them all back together, roughly, let's see here, very gingerly, whoopsie here, again, these do not match up, just to point that out again, which is okay. It's actually kind of funny. You can see on this particular piece that even though it was flight qualified, there's a couple places where there were problems with the manufacturing on one of these. Let's see, where is that? One of these has a big problem in it, and I don't remember where exactly it is. Oh, here it is. My finger is right on top of it. You can see here that this unit was actually damaged, and so it was flight qualified, design flight qualified, but it became scrap because it was damaged during the manufacturing process. So technically speaking, it was not flight qualified, but it was the design for the flight qualified units. And then this piece would have been sitting right there. So that gives you a little bit of an idea. All of these pieces are donated by individuals that worked on the mission. In this case, these were pieces from Rocket Research, and we have great appreciation for the individuals and the contractors who have donated these items to us, because without the context of all of these pieces and how they fit together and the information and diagrams that we are slowly aggregating to bring together into one location, without all that context and seeing how things work together, we wouldn't really be able to tell the true and full Viking story. Each one of the archives that we have contributes to our understanding of the whole system, and that means not just the units as they were built, but all of the tests that were done to get to this point for these designs that would ultimately bring us to the surface of Mars with the Viking mission. All of those archives are equally important because they tell us how we got to this configuration and why it was so successful. So thank you to all of our donors. Thank you to all of the contractors and subcontractors and NASA for all of your incredible work. But most importantly, those institutes are made up of individual people. So thank you to everyone that contributed to the Viking mission in every way. Each one of you is important to making the success of the mission, and we're grateful for your support.